So if we randomly add the plus 6 and minus 6, we can separate them. X squared plus 6x plus 13. And now, this bottom's derivative looks like this, right? Do you see it? This derivative will be 2x. This derivative will be 6. We see it right here. So this one can be u substitution. And this one is going to be the tangent part, because it no longer has an x in the top. So here we go, u equals x squared plus 6x plus 13. Du dx equals 2x plus 6, which means that du over 2x plus 6 equals dx. How about that? And why is that helpful? Because now I can rewrite this as 2x plus 6 over u, because I rewrote u, times, and then this is supposed to have a dx here, which I left off, because I have to replace the dx with du over 2x plus 6. And then these cancel. I have the integral of 1 over u du, which equals the natural log of absolute value of u, which is x squared plus 6x plus 13. So this part where you add these two, this is like a math magic trick. And with practice, you would come up with it. I honestly haven't seen them go this difficult on this test. I could see this being more Calc 2, maybe it might be on the BC exam more than it would be on the AB exam. I haven't seen it this difficult. But then we have to go figure out this part, which is where we will complete the square that I was doing up at the top. And we can rewrite this one as, so far I have, I'm going to rewrite pretty. You ready? 2x plus 6 over x squared plus 6x plus 13, simplified to natural log absolute value x squared plus 6x plus 13 absolute value. Then minus 6, integral of 1 over x squared plus 6x plus 13. And then I need the dx on this one, so I don't forget it. So this one I'm still working on. In my work from before, we added a 9, it subtracted a 9. That gave us negative 6, integral of 1 over, this is the 4 part. And this was the x squared plus 3x plus 3 all squared part. And let's look back at my pretty work that's done really pretty over here, where we have x squared plus 4, and then you had to substitute in again. So see, and I made a new note. This was a new way for me, which is why I had to go back and look at this, because it was hard for me as well. So there are substitution ways to plug back in for arctangent if you know how that simplifies. So here's my paper again. Paper. I say paper, but I can't find it. There it is. 4 plus x plus 3 all squared. And then you substitute the different parts in for tangent. So this means 2 squared plus x plus 3 squared. And then you had to plug in the different values. Instead of it being a straightforward x in tangent, it has other stuff. So this is next level, and I haven't seen it tested on the AP exam. But the final one was negative 6 over 2. That's this part that was squared. And then arctangent or tangent inverse, is it x plus 3 over 2? 3 over 2. And then that obviously reduces to 3 at the beginning. Let's look at my work and see if that's right. X plus 3 over 2. Oh, plus c. Stupid me. Okay, it's weird because y'all are all on mute, but it's much better when y'all talk to me, because then I feel not weird about all this talking to myself. And I'm looking for paper. Okay, so the final answer was this part, natural log, x plus 6x plus 13. minus 3 tangent inverse, or you can write arctangent here, x plus 3 over 2. And there's a formula for that hopefully I talked about in the video. They talk about it, they do it again in the examples in the book. They have several examples like that where they plug in the different variables. Have y'all pulled up any of the AP classroom videos? Because that also can be useful. But 35, I wouldn't test you on one this hard. I would maybe want you to complete the square so that you can get a more simple version of this. But it probably would have a 1 here, so it was more straightforward tangent inverse kind of problems. Yes, go, Finn. What? I don't think so. You're going to have several different integration techniques. So you're going to have to do long division for some. How was that? Was that easy? Yeah. What gets harder with the long division is recognizing when you're not in the section of long division, and you have to be like, oh, this one needs long division. Like that's what makes it harder. So we will have some practice where they're all mixed up, and we need to figure out the right tool for the thing. But that's where it gets harder. So I don't know that you also need to do multiple difficult integration techniques within, because we still have 3 different BC integration techniques that AB won't do. So we will have a lot of tools to use to integrate, and that will be the tricky part. Does that help, Ben? They'll be straightforward. Go ahead. I can't guarantee that there wouldn't be one, but I wouldn't think it would. I wouldn't test you on something this hard. This was practice that was interesting for us to go through, but not. I wouldn't test you on it. And I haven't seen problems like this on the AP exam. Now, when we do the BC practice exam, which I haven't done yet with a class, right? Because I haven't had this class before. Could there be a problem here or there? If so, we'll find it on the practice exam and the practice exams we do before the exam. And by then we'll be really good at integrating, so it won't be a big deal. But plainly speaking, I think it's going to be a matter of, here's something to integrate. Can you figure out what method is going to work for this problem? Okay, other questions? How did I know? It's right here, this part, Luke? Okay, did you see my note on my paper that I posted? I learned something new when I did this problem originally. So, like, are you talking about adding the 6 to the 2x part? It's because when I did the complete the square on the bottom and I got to here, I was stuck because this 2x wasn't the derivative of anything in the bottom. So tangent wasn't going to solve the problem for me. So, and I'm going to be completely upfront. I looked up how to do this problem because adding the 6 and subtracting the 6 to the top, this math magic, was not something that I came up with. It was something that I learned from doing this particular homework problem. And you saw me this year go look it up because I didn't remember how to do it either. Because it's not something that I've seen a lot of. And the reason you'll have a lot of homework problems to practice is so you get good at spotting what you're supposed to do. Having done one last year, I didn't remember, you know? But it's interesting. And I hope that it will stick and I'll come up with it on my own later to try. But it didn't occur to me today. So I didn't, Luke. I mean, I got help. I mean, that's no reason for me to tell you I'm a genius. I'm all right, but you know. Okay, what else can we go through? Was this the last section we did, inverse trig? Yeah. Did you have a circuit to do? Or is this what was homework that was due today? Because I don't remember. Okay. Okay. So we've got a circuit that we'll do maybe this coming weekend that'll be inverse trig that you have answers and I've done the whole circuit and I remember it starting to flow as we got through it and I could pick out the different ones really quickly. So that's coming and that'll be good and it practices the different techniques that we've got going on. This is actually the last section of this chapter. And I can't give you a test when I haven't seen you in person for several days. So we will do some other integration techniques that mostly deal with fractions, also reverse product rule. But we'll get those together. Maybe we'll do like a practice test so that I'll know that we're on the same page. Things that might answer like Ben's question, like what would you ask us because we haven't had those days together. You'd feel comfortable what we're doing and that you had a chance to practice stuff. So that's kind of my goal going forward. Other particular problems you want to look at that you couldn't get on Calc Chat or my notes? No? Okay. If you think of one, you can add it to comments for the Zoom. That would be the place to put it so that I can collect them all into one thought to talk about in a video since I don't see you in person tomorrow. I don't know what's supposed to happen tomorrow because Thursday, if we come to class, it will be a whole day of class. So I'm going to assume, see, that's weird because do y'all see what I'm having trouble figuring out? Yeah, so I don't theoretically know because we don't have double blocks on Thursday. Right, right. I don't know. Right. Um, so I don't have specific homework for you tonight, and I don't know what's going to happen with the weather. So I don't know that I'll actually see you on Friday, but I will have an assignment that has an FRQ, and I may ask you to do like a flip grid where you explain what's happening in the picture in terms of an actual event. So I told you that I have one that's for snowfall, and the idea of it is to make some of the ideas that we have concrete with regard to what it means to have a graph and to integrate it versus take a derivative, like what the different things say in a real context kind of situation. So hopefully some of this math will make sense. That's the goal. And in the meantime, y'all just let me know what other questions I haven't worked through fully. And maybe even ask me, hey, this one was really hard for me. Do you see this being a problem that might be actually on the AP exam or that you're going to test us on? And if so, could we do it? You know what I mean? Yeah. Okay. Rest of you are really quiet. Okay, one day y'all are going to have to lead Zooms because this is not going away. And you're going to be like, oh man, we left Miss hanging and we just quiet. And then she videoed it and shared it with the other 5 people who weren't in class because they were RCS this morning. And you're going to feel bad and you're going to write me a letter. I'm just kidding. Okay. Okay, so I need for you just to let me know what other questions you have, unless there's something you think of right now that you want to do. We theoretically have 8 minutes, or I can let you go. Okay. Well, these were, yeah, I know. I'm sorry that you're stuck in the snow. It is pretty though. Well, just let me know. Do what? You want to go home? Yeah. Yeah, but you don't want to be on the highway stuck like the people in Virginia that day. Yeah. No, that would be bad. Okay. Okay, y'all. Well, have a good day. I hope the rest of your day is as easy as this class. And I'll see you later. Okay? Okay, bye.